Alright, this is the video that goes along with the Unit 1 practice problems for the exam. I'm going to go through the steps for all 6 of these calculations. And remember, if you write out the steps, fill this out, it will be useful because you can use this on the exam. Alright, so as you go through these, don't find yourself just letting me do it. Alright, I'll try to go slow. It's hard when I'm sitting here alone in the dark to know how fast to go. But you would want to make sure that you have this formula sheet and then a calculator available to you. Alright, even if it's a calculator on your phone or whatever, make sure you're going through these in order to get the most out of it. Alright, Unit 1. This dealt with speed, acceleration. Alright, just kind of some pretty basic stuff to get us started. And remember, always check out units in problems, and then that will always help to determine the formula. So, a football is thrown a distance of 60 meters. That's a distance. In 1.5 seconds. That's a time. Looking for average speed. The word average, if there's only one distance in time, it's not significant. But if you see the word average and you see 2 distances and 2 times, you've really got to pay attention to what's going on. Alright, but for this one, since there's only one distance or only one time, it really doesn't matter if you use the speed formula or the average speed, because it's just distance divided by time. So speed, I know V is for velocity, but scientists usually, physicists, just use the V anyways. It's distance divided by time, so it's 60 meters divided by 1.5 seconds. And you plug that in. So we go 60 divided by 1.5, and we get 40. Now this says round to the nearest tenth. Don't let me get in your head. I just copy and paste. So like when I make all these practice problems, I'll copy and paste and then just change numbers. So sometimes you actually have to actively round, and sometimes it's just if it's there, round to the nearest tenth. This doesn't have a tenth, it's a 0. So answer is 40 meters per second. And remember, in Moodle, you just type in the number, never the units of measurement. Alright, next one here. Try to focus that a little bit. A lion has the ability to run at a speed of 48 miles an hour. There's a speed. At this pace, how many miles? Miles is a distance. Will the lion have covered in 0.25 hours? That's a time. Okay, so this is a case where we use the speed formula for something other than to find the speed, because we already have that. And for this one, I had already rearranged it on your formula sheets back in August or early September when we were at this part of the unit, unless you have me in the winter trimester, then who knows when it was, November. All right, but early on. So if we're looking for distance, we know it's speed multiplied by time. Okay, so we've got a multiplication here. So it's going to be 48 multiplied by 0.25. Okay, so 48 times 0.25, and that means that the lion will have covered 12 miles. That's pretty realistic. Scary but true. I googled some of the, like, what is the average speed of a lion and all that good stuff. So I don't think anybody's going to outrun that one. Number 3. A person jogs 5 miles. There's a distance. It takes her 0.75 hours. There's a time. Uh-oh. She turns around, jogs 3 miles. Distance. Takes her an additional hour. Ooh, she's slowing down. This is one where, okay, we want average speed, but we have 2 different distances, 2 different times. So when you look at that formula sheet, we know that average speed is total distance divided by total time. Total means we add. All right, total means we add. So we go total distances. So it's 5 miles, and we add the 3 miles back home. Those go on top. And then your total times is 1 hour plus the 0.75 hours. So we have 8 miles divided by 1.75 hours. So plug that in. 8 divided by 1.75. Alright, good. This is one we actually have to round. So we have 4.57. Remember, round to the 10th means we have to use this number. So we look to its right door neighbor. A 7 is 5 and above, which means we round this up to a 6. So your final answer here would be 4.6 miles per hour. Okay, 4.6 miles per hour. Alright, switching gears a little bit. That was all speed and how far, time stuff. Now we're looking for acceleration. Remember, acceleration is how fast or how slow you speed up or slow down. So like how long does it take? It's a rate that you change your velocity. There's more things to look for now. Okay, so this is where we wrote it out like this on your formula sheet. So acceleration is the final speed, subtract the initial speed, divided by how long that takes. So final speed at the end of the story, how fast was it going at the beginning of the story, and then divide it by how long that change in velocity took. Alright, an apple begins at rest, attached to a branch. That's important. It begins at rest. So you got a VI right there, and it's going to end up being 0. Because it's not moving. We have a fat bird, lands on the branch, apple begins to fall. It takes 1.5 seconds, there's the time, for the apple to hit the ground at a velocity of 12. So it hits at 12 meters per second. That's your final velocity. What was the acceleration? That's an A. Of the apple, meters per second squared is the unit, it's just the unit. So our formula is the final velocity, subtract the initial velocity, divided by how long that took. So it's going to be 12. That's how fast it hit the ground, starts at rest, and we divide it by 1.5. So essentially we have 12 divided by 1.5. Answer is 8. So the acceleration of that apple was 8 meters per second squared. So every second it would have fallen, it would have increased its velocity by 8 meters per second. Number 5, same process. A softball is hit off a bat and accelerates to a velocity of 65 miles an hour just at 1.25 seconds after leaving the bat. Assume the starting speed of the ball when it collides with the bat and reverses direction is 0. Remember when we did this back in the learning target, we struggled with this a little bit. It says the starting speed. So that is our VI. Our initial speed is 0, which means the final speed in this case is 65. Okay, so our final speed is 65, our initial speed is 0. We have a time of 1.25 seconds. Acceleration equals VF minus VI divided by time. So it's going to be 65 minus 0. Time is 1.25. So 65 divided by 1.25 is 52. It's a pretty good swing on that ball there. So it's 52 miles per hour squared. That part doesn't really matter. The answer is 52. Alright, so we've got a situation where something is speeding up both times. Now we're going to have one where we're slowing down. Okay, that's still acceleration. It's just a negative type of acceleration. So we have a car moving at a speed of 45 kilometers an hour. Driver spots a turtle crossing the road. The turtle-loving driver slams on the brakes, brings the car to a stop in 2.5 seconds. What was the acceleration? So this time, you're cruising at 45. I'm going to put it down here because there's no room. So the initial speed is 45. You see the turtle, you're going to stop because you don't want to hit it. So your final speed is 0, and it takes you 2.5 seconds to do that. So I think that could be a bad day for that turtle if it takes you that long to stop. Alright, acceleration is VF minus VI divided by time. Here's the kicker. We see a 0, sometimes we like to ignore it. We can't, because by putting that 0 in for the final velocity, it's going to give you a negative answer, which should be true, because a negative acceleration means we are slowing down. So we slow down over 2.5 seconds. So I'm going to go 0 minus 45 gives us the negative 45. We divide that by the 2.5 seconds, which means you're slowing down at a rate of negative 18 kilometers per hour per second. All right, don't get lost in the units. What's important is that you're slowing down by negative 18. So always stop yourself in these types of problems. Before you put that answer into Moodle, make sure you think, all right, were they speeding up or slowing down? Because if you have a situation where something is slowing down, that should have been negative. So recheck your work at that point. All right, so probably not all-inclusive, but this is enough that it should be helpful for the Unit 1 portion on the final exam.